Hi everyone, so this is our intake design. It is currently printed out of PETG because it's impact resistant. We had trouble with our previous one breaking. Anyway, so it is a top roller and a static flexible polycarb flap on the bottom. This was originally Delrin, originally wasn't bent, but we played around with it and tried to find what worked best. This seemed to be the best thing. Started off as core flute, then went to Delrin, then polycarb. Just like messing around, testing what worked. The top rollers are just these ever so slightly squishy, like not very much, Rev rubber wheels. We would have liked to use some more compliant wheels, but you get what you get. It is powered off a Axon Max, not very fast, but it's on a 2-to-1, a 1-to-2 increase in speed. This was just because it was faster at picking up game pieces. We would have liked to also make this faster, use either a Go Builder Speed that we couldn't find in the workshop or an Axon Mini, but you know, run out of time, things happen. We have Mechan wheels on either side so that when we extend this out, it maintains the same height no matter where we are in our extension range. It's that. There's actually a lot of, you might have seen in the rubber reveal video, there's actually a lot of area where this will pick it up and look really sketchy, but still hold it really nicely, which is always good. We also have been getting a lot of comments about if we can pick up with the clips on them. It works, we've tested it. We just ran out of time with actually placing them on our chamber. We just kind of like ran out of time of like figuring out all the finicky parts, getting the code sorted, because you have to, you know, run it slightly out as you're dropping it down. And we knew we had the capability. We just chose to focus on just consistently scoring. As we also decided that the basket was a better time efficiency and like productive cycle for a robot in 30 hours. Yeah, we also have our spring for our extension out on here, as it is obviously the last part of the robot. Yeah, that's it.
Hi, I'm Riley from the Gong Invaders. I'm here to talk about our arm subsystem. So for our extension, we're using Actobotics linear extrusion rail kit. So this allows us to keep it pretty compact and rigid at the same time. And so we've got pretty smooth extension. As for our pivot, we're running a 60-to-1 Neverest motor, as well as a 3-to-1 chain reduction. So we're essentially getting 181 off the bare motor, and it's still really fast. And that sort of allows us to get good strength on our pivot, so we can keep our arm up at the height to deliver on the high bucket. As for our extension, we're actually running a 3.7-to-1 motor because that's essentially all we had, but we found it to work really well. And with a good PID tune, it moves in and out at a really nice speed while still being quite controllable. So yeah, we found that works really well for us. But obviously you can change that to be slower to get even more control. And same again with the reduction, you could put an even slower motor on this. For example, the Rev motors with the ultraplanetary cartridges, you could bring it down even slower so you have really nice control and you don't have to worry about the arms sagging down. So yeah, that's pretty much everything.
This is our climb concept that we've got. It's a bit half-baked, but we built it off the bot. So this leg goes down and tilts the robot up. It eventually ends up in this position where we then winch up. Our arm would be forwards and extend out to the arm. So the arm would extend out and that would adjust our center of gravity. Well, that snapped. That's fine, we didn't need that stage anyway. So let's return to this position, I guess. Then we would extend the second stage, put the arm out to bring our CG forwards, and then we would pull up have angled parts on the chassis here that would, as this comes up, push it out to the side, and it would continue to climb. Currently, because of that thing that just broke, it doesn't go all the way, but it would go all the way and then swing here, and we would be climbed. So that's how it would work in theory. In practice, we didn't quite get there, but we hope to see a similar climb concept like this done by one of you guys. So looking forward to it. So this is our slightly unfinished climber plan for the level 3 climb for the robot in 30 hours challenge. We have a linear servo that pushes down to tilt the robot, and then a 2-stage independently driven elevator lift thingy to do the 2 stages of climb. So
down on the servo. Yeah, so this is sort of inspired by some 2019 FRC climbs where they pushed off underneath the robot. So we have this arm under here, and so it's slowly moving its way up. And so this is so we can get onto the claws up the top. So it's going nice and slow.
There we go. So we lock on to, by tilting the robot, we can get the hooks that are at our center of gravity over the first bar. And then we can drop this leg.
Nice.
A little bit slow. So we drop the leg out of the way, and then we can, we'll use the motor and we'll winch down on our first stage of our climber. Yep. Slowly does it. Ping. What's going on?
I just don't want to snap stuff, but
I'll slightly support the back if we need to.
there we go.
Yep.
So up.
Up, all the way. What?
String snap.
String snapped.
Okay, we keep going.
Anyway, so what it does is it winches the robot up to this state. We have our arm come down and out to shift our center of gravity. Well, okay, it's fully snapped now. Okay, so we climb with our first hooks here.
Yep.
We shift our arm out to shift the center of gravity back enough so that these hooks clear and then come in. And then we climb the rest of the way with these hooks up and over.
Yeah, and so adding ramps on the front will sort of let the robot slide past this the first bar.
So do you want to grab a piece of metal?
I can, yep. Sort of like this.
So I have an angle on the front of the bot, so that as it comes up in contact with the bar is pushed out of the way, and then the robot goes on top. And it has just enough room to clear the bar. The system that we're working with, these slides are suboptimal for this, but this was just kind of a proof of concept climb to show that this geometry would work and the idea itself would work. So yeah, that was a scuffed explainer, but
Definitely tricky, but worth doing for the 15 points. Yeah.
30 points.
Extra 15. Yeah.
Extra 15, okay, yeah.
Alrighty.
Yeah, that's about it.